Exercise 6.1, question 1. Which of the following numbers are not perfect cubes? First question is 216. To find out this, let us prime factorize the given number. First number is 216. Let us divide it by 2 as it is a even number. So we get 108. Divide that by 2 as it is even. So we get 54, which is divisible by 2, and the quotient is 27. Now this is not divisible by 2, which is divisible by 3. Quotient is 9, which is divisible by 3, 3, 3 and 1. 216 is equal to 2 into 2 into 2 into 3 into 3 into 3. The prime factors of 216 can be divided in groups of 3. Therefore, 216 is a perfect cube. Now let us solve next question, and that is 128. Prime factorization of 128. Which is an even number, so divided by 2, quotient is 64, divide that by 2, quotient is 32, divided by 2 to get 16, divided by 2 to get 8, divided by 2 to get 4, divided by 2 to get 2, divided by 2 to get 1. 128 is equal to 1, 2, 3, 4, 5, 6, 7. Now prime factor 2, 1 prime factor 2 does not form a group of 3. 2 does not form group of 3. Therefore, 128 is not a perfect cube. Find the smallest number by which each of the following number must be multiplied to obtain a perfect cube. Let us solve 243. The method is same, it is prime factorization. This is odd number, not divisible by 2, but sum of the digits is 2 plus 4 is 6, 6 plus 3 is 9, which is multiple of 3. So we can divide it by 3. 8s are, 1s are. This number is multiple of 3. Quotient is 27. Divisible by 3. Quotient is 9. Divisible by 3. Quotient is 3. Divisible by 3 and 1. Now the prime factor (3 into 3). There are two 3's which do not form a triplet. The prime factors 3 and 3 does not appear in a group of 3. Therefore, 243 is not a perfect cube. To make it a cube, we need one more 3. So in that case, 243, it is 3 into 3 into 3. We multiply both the sides by 3. Now this is a perfect cube. 729 which is a perfect cube. So we must multiply 243 by 3 to obtain a perfect cube. Find the smallest number by which each of the following number must be divided to obtain a perfect cube. Divided by. Number is 81, or let us consider another one, 135. This number is not divisible by 2 because it is odd. Sum of digits is 9, so it is divisible by 3. 3 4s are 12, remainder is 1 and that 5, so 3 5s are 15. This number is divisible by 3. Quotient is 15, which is divisible by 3. 5 5 1. The prime 5 does not appear in a group of 3. So 135 is not a perfect cube. Now we must divide 135 by 5 because this 5 is not forming group of 3. So 135 is equal to 3 into 3 into 3 into 5. To cancel this 5 we divide both sides by 5. This 5 will get cancelled and 135 divided by 5 is 27, which is perfect cube. So 135 must be divided by 5 to obtain a perfect cube. Parikshit makes a cube of plasticine of sides phi 2 and phi. How many such cuboids will he need to form a cube? Now let us go through a solved question. There is one such solved question. Raj made a cuboid of plasticine. Length, breadth and height of cuboid are 15, 30 and 15. Anu asked how many such cuboids will she need to make a perfect cube. Volume of a cuboid is length into breadth into height. So it is 15 into 30 into 15. Now prime factorize these numbers. This 15 is factorized as 3 into 5. 30 is factorized as 2 into 3 into 5 and this 15 as 3 into 5. Rearranging them, we find that 3 prime factor 3 forms a triplet and 5 also forms a triplet. So to make this or complete this triplet, we must multiply by 4, that is 2 into 2. So to make a perfect cube, therefore we need 4 such cuboid to make a cube. Let us solve the exercise question. Volume is volume of cuboid is length into breadth into height. In this case it is 5 into 2 into 5. Now this 5 does not form a triplet and 2 also does not form a triplet, so we multiply, or we need to multiply by 1 5 and 2 2's to form a perfect cube. Since there is only 1 2 in the prime factorization, here we need to write there is only 1 2 and 2 5's, or 2 times 5. Therefore we need 2 into 2 and 5, that is 20, to form a cube. Twenty cuboids. To form a cube. Cube roots. If volume of cube is 125 centimeter cube, what would be the length of its side? Now 125 is cube of 5, so cube root of 125 is 5. 1 cube is 1, so cube root of 1 is 1. 2 cube is 8, so cube root of 8 is 2. Similarly, 3 cube is 27, cube root of 27 is 3. 4 cube is 64, so cube root of 64 is 4. Cube root through prime factorization method. Consider 3375. We find its cube root by prime factorization method. 3375 is prime factorized and we get a triplet of 3 and 5. That can be written as 3 cube into 5 cube, that is 3 into 5 whole cube. Therefore, cube root of 3375 is 3 into 5. We consider once for a triplet and cube root is 15. Now let us find cube root of 74088. Number is divisible by 2. 37044, which is divisible by 2. 18522 9261. 9261 is a cube, but now this is not divisible by 2. We divide this by 3. Then 0 8 7 1 0 9 3 3s are 4s are 3s are. This is 7 cube. So 74088 is 2 into 2 into 2 into 3 into 3 into 3 into 7 into 7 into 7, which is 2 cube into 3 cube into 7 cube. That can be written as 2 into 3 into 7 cube. Therefore, cube root of 74088 is 42. cube of any odd number, cube of a even number is even and cube of odd number is odd, cube of positive number is positive, cube of negative number is negative, cube of any odd number is even. This statement is false. A perfect cube does not end with 2 zeros. It has to end with 3 zeros, 6 zeros. So number of zeros must be multiple of 3. So 2 is not multiple of 3. So this statement, cube does not end with 2 zeros. Yes, this statement is true. If a square of number ends with 5, then its cube ends with 2 5. Let us check this. Square of a number ends with 5. 15. Or let us consider 5. Square is 25 and cube is 125. For 15, square is 225 and cube is 3375. Just now we have seen here 3375, cube root is 15, so cube does not end with 25. This statement is false. There is no perfect cube which ends with 8, There can be cube which ends with 8. 2 cube is 8, then 12 cube is 1728. So it ends with 8. This is false. The cube of 2-digit number may be a 3-digit number. Let us consider a 2-digit number. Its cube is 1000. It contains 4 digit. 11 cube is 1331. So cube of 2-digit number is a 4-digit number. This statement is false. Cube of 2-digit number may be 7 or more digits. Cube of 2-digit number. Which is the greatest 2-digit number? Greatest 2-digit number is 99. Cube of 99. Or let us find out cube of 100. 100 contains 2 zeros. Therefore, its cube will contain 6 zeros. So this is a 7-digit. 1, 2, 3, 4, 5, 6, 7. And this is the smallest 7-digit number. So 99 cube will not have 7 or more digits. It will have less than 7 digits. Let us check this. It contains 6 digits. So this statement is false. A cube of single-digit number may be a single-digit number. No, this is also false. Because 5 is a single digit, but its cube is 125. Maybe. So if we consider 1 cube is 1. 2 cube is 8. The cube of 1 and 2 is a single digit number. Cube of single digit number may be. Yes, it is. We are not sure about it. Or in general, this statement is false, but that is true for specific numbers. So as here we have maybe, we read this statement as